Assalamu alaikum everyone and welcome to physiochem.acadmey. As we had discussed about the thermoanalytical method and thermogravimetric analysis, in this lecture we are going to discuss some basic points about the thermogravimetric analysis and we will start from temperature. In case of temperature, we have total three terms which are used in case of temperature. The very first one is room temperature, second one is ambient temperature, and the third one is peak temperature. Now, looking at the term room temperature, being a chemist, everyone know that room temperature is between 20 to 25 degrees centigrade for every experiment. In the same way, ambient temperature is the temperature of sample before heating it. Like when we put our sample in our crucible, or we can say in our furnace for heating purposes, or we can say for our analysis, and we measure its temperature before heating it, that temperature will be its ambient temperature. In the same way, if you look at peak temperature, so peak temperature is that temperature beyond which no change occur in weight of sample on further heating. So as I already mentioned that for polymer, the thermogram will look like this. It will be a multiple curve thermogram, and by multiple curve we mean here are more than one curve in this, and we are trying to explain peak temperature with the help of this thermogram. Here it is, we take our mass, and here we take our temperature in degree centigrade. So peak temperature will be different for every curve. As we increase the temperature, let's say here it is 45 degrees centigrade. Now, as we increase temperature from 0 to 45 degrees centigrade, here the changes will occur, and a time will reach here that the changes that occur in our sample will be stopped. So at this temperature, where maximum change occur in the weight of our sample for one peak, that will be the peak temperature for that curve. So peak temperature literally for every polymer will be more than one. For every curve there will be a separate peak temperature. Now moving down, let me make some space so that we can write. Our second term which we are going to explain is about the thermogram. As I have already cleared that thermogram are the graph which are obtained during the thermogravimetric analysis. So we can say that all the graph which are obtained in thermoanalytical method, either it is thermogravimetric analysis, or it is differential scanning calorimetry, or any one of the thermoanalytical method, the graph obtained we will call the thermogram. Now two type of graph are basically obtained. The very first one is single step thermogram. And single step thermogram, if I draw it like this, it is a single step thermogram, and by this thermogram we will deduce that here only the drying processes occur. And we can say that only our moisture content or we can say surface water has been removed. This type of single strip thermogram is not possible in case of polymer. In polymer case, this is not possible in case of polymer case. So in polymer case, we will obtain a thermogram, we will come across a thermogram which will usually be like this, as I draw it before. It will be a multiple shape or multiple curve thermogram in case of polymer, because polymer are actually complex molecule which contain different type of bond. And we can say that each bond require its own specific energy for its dissociation. So therefore, in case of polymer, we will obtain a thermogram that will be multiple curve. In the same way, if we discuss it more about the steps, so from 0 to up to 100 degrees centigrade. Up to 100 degrees centigrade, we can say that here only the surface water or moisture content will be removed. Only evaporation will occur in this case, up to 100 degrees centigrade. Or we can say that only the volatile substances which are present in our substance and our sample will be removed up to 100 degrees centigrade. And this will be counted as physical change. Now, up to 200 degrees centigrade, we can say that the entrap water or we can say water present inside. Up to 100 degrees, 200 degrees centigrade entrap water, or we can say water which are present inside our sample will be removed up to 200 degrees centigrade. Or we can also say that low boiling point substances will remove in this up to this 200 degrees centigrade. Now, beyond 250 degrees centigrade, here up to 200 degrees centigrade, you can also expect some chemical changes. But we cannot surely say that chemical changes will occur up to 200 degrees centigrade. But beyond 250 degrees centigrade, chemical changes will be observed, and our compound will face chemical changes. Now, if we move further, there are two terms which are used. The very first one, and they are confusing with each other. Many times we confuse these two terms and mix these two terms with each other. The very first one is decomposition, and the second one is degradation. One term which I also want to add here, the curve which are present in our thermogram for a polymer case, how much of the curve are obtained are we see in our thermogram. Like here it is the first one, the second one, and the third one. So here we can say that here three processes occur. So how much is our curve in our thermogram? We will say that in the same way, similarly, chemical changes has occurred. So no, decomposition and degradation. Decomposition. After decomposition, we can say that our substance can further be decomposed. There is chances after decomposition that our compound may further be decomposed. In the same way, degradation is the final step, and after degradation we will came across our product in the degraded form. So if I consider here a substance A, and let I say that here this compound has decomposed. So here we may face another compound or its constituent in the form of B and C, and after that we may face, if it's further decomposed, we may say that here D and E has obtained, and here this compound is changed or decomposed to F. Now if we say that this compound has now degraded, if we say that D, C and F has been degraded, so after degradation here we will came across the product in degraded form. So these are the two terms which are basically confused with each other, and people don't understand them properly. Now moving into the next step, here are some other basic points. The very first one is why we use furnace for heating purposes and not oven. So here if we look at the heating capacity of oven, it can be at a temperature up to 300 degrees centigrade, and if we look at furnace, it can be at a temperature up to 1000 to 1200 degrees centigrade. Now here are the substances in the form like metal oxide preparation, metal oxide composite preparation, and many more substances are composite are there that require a huge heat, that require a high level of heat. So for these purposes, if we heat them in oven, if we heat them in oven, our oven will be degraded, and as I say that the substance which we use for the heating purpose should be inert one and should not degrade. Should be stable. So therefore we cannot use oven and we use furnace just because of these two reasons, that furnace is stable at high temperature and it's also inert. So therefore we use furnace for the heating purposes and not the oven. Another very basic point is this, as we have used molecular weight and compositional analysis. So molecular weight is one of the basic thing which you will be used for calculating different substances, which substance has been evolved or removed at in which particular curve. So for this you need the molecular weight of your sample. Now there are some cases where you would not be familiar with the molecular weight of your sample. So in order to so for those cases we will couple if we don't know the molecular weight of our sample under investigation, then we will couple our TGA device with the IR device. And as we know that IR device tell us about the functional group. And this gave us information about the function group, and each function group has some specific temperature range. Like if it gave us the temperature range of if you observe a peak in IR device between this temperature range, we will deduce that our sample or our compound contain carbonyl function group. In the same way, if you observe a peak in this temperature range, we can easily say that here our hydroxyl function group is present. So in this way, we can easily calculate the molecular weight of our compound. Now, one more point which I like to add it here. If we came across a broader peak like this one, there are two. Basically, you would observe two type of peak: broader peak and sharp peak. This one is sharp peak, and this one is broader peak. Now, if we observe a broader peak in our analysis, we would say we will deduce that here our hydrogen bonding is present in our sample, and here we would say that hydrogen bonding is not present in our sample. So these are some basic point in term which are necessary while performing the thermogravimetric analysis. And in the next video, we would discuss about the degradation kinetics. So for now, thank you very much for watching this video. Allah Hafiz.